So, hello, good afternoon, everyone. I hope you're all doing well today. Let me just start by sharing my screen with you all with the slide deck. Desktop 2. So yes, just to check with my fellow participants, you can see the screen. Fantastic, cool. Well, good afternoon, everyone, and welcome to our latest M2A Talks webinar here discussing collaboration in the cloud, live motion compensated frame rate conversion. So today, this webinar is brought to you by the teams at M2A Media, InSync Technology and Hiscale. So it's great to have you all. Fortunately, we won't see any of you at IBC due to its cancellation, but this is the next best thing. So we'll just begin with a little bit of housekeeping. So if you are going to ask questions, please use the Q&A feature within Zoom. Here you'll be able to drop us a question and then we will answer it with our panel at the end of the session. If you wish to watch this again after the event, you will receive a catch-up link hosted on the Zoom cloud platform. This will allow you to watch back or if you want to have a review of what was talked about. And finally, you know, the modern digital age we're in, please connect with us as panelists or me as the moderator on LinkedIn or follow our respective companies there as well. You'll find links to everybody in the chat section of the Zoom platform. So without further ado, let's move on and introduce our panel today. So I'm quite excited to invite our experts on the panel. Who we've got is Valentijn Siebrands, who's joining us live from the Netherlands, James Shepherd, CTO of InSync Technology, live from the UK, and finally, Christoph Jurkuhn, who is Product and Presales at Hiscale, based over in Germany. So good to see you all today. Thank you for being with us. If I could invite James to just give us a quick intro into InSync for our audience.
Thanks, Callum. Yeah, so InSync Technology are specialists in image manipulation. That is the algorithms and the digital signal processing needed to transform and convert video media. So here at InSync, we research and develop our own proprietary solutions to all aspects of the conversion problem, including, for example, wide color gamut, high dynamic range, deinterlacing, and in particular, motion compensated interpolation. So we really focus here on the problems for which there's no ground truth, problems which have no pre-described definitive solution. Originally, we delivered our implementations in hardware, and then subsequently we've evolved to supply our IP portfolio as software, libraries, services, and standalone solutions.
Great, thank you, James. Now over to Valentijn for M2A Media.
M2A Media are innovators in cloud broadcast. We help video publishers to quickly and easily harness the flexible, scalable benefits for the cloud or in the cloud for live video, allowing them to transition away from legacy technologies, which can be costly and inflexible. Our latest product is M2A CONNECT, which aggregates and distributes live video streams using public cloud. It is a simple to use, feature-rich product for scalable transport of live video.
Nice and short. Thank you, Valentijn. And finally, Christoph, if you could introduce Hiscale to the audience.
Yes, thanks, Callum. So Hiscale is a software development company based in Germany, focusing on developing scalable media processing solutions. We have a transcoding product portfolio, which includes solutions for file-based, video on demand, and live conversions. We also have products focusing on file-based workflow orchestration, as well as on live video distribution.
Thank you, Christoph. Fantastic. So just making us start, James, you know, you and the InSync guys, you've been around for a couple of decades now. you really have, as a company and yourself, a depth of experience when it comes to frame rate conversion. Would you mind, for some of the audience who may not be entirely clear on frame rate conversion, just taking a step back and looking at the evolution of the technology since you began working in the field?
Absolutely. So if we can start on this very simple slide that really introduces the topic. From the outset of television, the world has been divided into those territories that produce and distribute their content at a normally 60 hertz rate versus those that do the same at 50 hertz. And really, this baked in a fantastically difficult problem for the industry, as crossing that frame rate divide is a fundamentally challenging process. There may be those in the audience who are concerned that I've neglected to comment on other frame rates, such as 24 frames per second. I'm going to put those to one side for today, predominantly because these low frame rates are ultimately technically incapable of high quality motion portrayal. So although we're very accustomed to the stylistic appearance, it's in fact that technical limitation that means that there are other more procedural ways that that content can be shared internationally. So our focus here for this application is one of preserving high quality naturalistic motion portrayal, which is a key requirement of any high quality sports distribution. So we might wonder what can go wrong, what's the issue at hand here. If we simply take image content from the source standard and reproduce it at the complementary frame rate, or if we try to combine or blend it in some way, ultimately for every moving component within the image, we're going to display it at the wrong place and at the wrong time. And the consequences of that is that all motion within the image becomes uneven and ununiform. And in the industry, we have terminology for that typically described as judder or stutter. And ultimately, because we can't eye track that uneven movement, the end result to the end viewer is one of double or multiple imaging. Now, if we go to the next slide, I apologize in advance that it's extremely unpleasant to look at, and that's entirely the point. What we can see here is a simple piece of text, multiply imaged as it would be for a variety of speeds. And even at low speeds, what we've lost is the clarity, the fidelity, the detail. So if this text happened to be our brand or our sponsor or our premium talent on the pitch, the investment that's been made in high production values in the original capture of the content is ultimately potentially being entirely lost by the time that reaches the end customer. And I think that would be a concern for a high quality service. Now, fortunately, there is a solution, and just one solution, which correctly deals with that problem, and that's to apply motion compensated conversion. Now, this is an inherently technically and computationally difficult task. We have to motion estimate, we have to measure the motion of every moving element within the image. And so traditionally, this has only been capable of being delivered by dedicated hardware technologies. But over the last 25 years, we've seen this endless growth in the capability of microprocessors and their ability to deal live with increasing bandwidth and increasing processing complexity. But motion compensated standards conversion as a process has been out of reach until now. So InSync Technology is extremely proud to bring the frameformer conversion technology to the market as the first high quality motion compensated standards conversion solution in software that can operate on generic CPU technology. And this is a fundamental enabler for deployment in virtualized and cloud environments. And it is also an enabler for freely scaling that process. Now, there are other software solutions available, but they are dependent on specific GPU, if not turnkey systems, or they don't support the live function. Now, I've stressed this question of scalability, so let's see why that would be so relevant in this context. So this slide is illustrating the top 3 premium sports events in the world, namely the Summer and Winter Games and the World Cup. Now, these events attract the highest global viewing figures of any form of television, the figures here being given in billions. And we can see the pattern of distribution on 2- and 4-year cycles. But these events last just a few weeks. So historically, provisioning the hardware to address the conversion requirement has been an immensely difficult challenge, because these units are a major capital expenditure. And in order to return on that kind of investment, we would normally expect to run that sort of kit 24/7. So the ability to deliver an on-demand cloud-based virtualized solution at high quality is set to revolutionize the availability of this process, rendering it both simple and cost-effective. Now, currently, so far, all I've described is the core conversion process itself. But in order to integrate into real-world signal flows, and especially if we want to achieve that in the cloud and in the public cloud, then we have to be concerned with dealing with encoded streams. The motion-compensated conversion is InSync's core competence. And in delivering this to the market, we sought out a transcode partner with expertise, and in particular, the same vision of free, flexible cloud deployment and scalability. So it's at this point that I'd like to introduce Christoph from Hiscale to talk about their transcode technology.
Thank you, James. So at Hiscale, we have developed our transcoding products, Flix, with broadcast customers in mind to solve scaling issues that they were usually facing using traditional on-premise static transcoding solutions. So Flix products are Linux-based Dockerized applications that can be deployed in traditional server hardware, in on-premise data centers. They can be deployed in virtual machines, and they can be deployed in the cloud, giving customers the ability to configure hybrid setups utilizing on-premise resources and dynamically scaling into the cloud as well. We have started developing our products with file conversions and video on demand conversions, and brought those to the market. And we have expanded our Flix product family with our scalable Flix Live encoder as a software-only solution for live encoding use cases. Now, listening to our customers' needs, we were also been asked for high-quality frame rate conversion in our transcoding pipeline. And this is where we have come to collaborate with InSync Technology and use their frameformer component in our transcoding pipeline, which is the picture everyone is staring at all the time, wondering what is this? So there's a high level, really high level view of a transcoder that we deploy. So if you might just go back a slide, sorry. So this is the transcoding pipeline, which is essentially what is deployed in one of these transcoding Docker containers. And that's not particularly different than other transcoding solutions, because transcoding goes through the same sort of cycle when you're looking at the same use cases. And in particular, with the live use case, it starts with decoding. So you read in the IP-based source in this case. And then you can do optional processing on the raw images that you have, which could be things like overlays, or also more complicated tasks like motion compensated frame rate conversion. And then you have the encoding step, which is then writing the desired codec and format and streaming that out. So now we can move on to the next slide. That's obviously a screenshot of our Flix transcoding product, of one of the configuration pages. So dealing with transcoding in general, there's always many things to consider, and things that need to be configured according to desired codec specifications, qualities, speeds, and a lot more. And at the end of the day, you have to really dig into these applications and get your head around all the configurations and how they work together. And that's a typical broadcast engineer's day-to-day job, figuring these things out. And they know all too well how this works. And it's definitely worth the effort for solutions that you run yourself, being on-premise or in your own cloud account. Now, this is also something that has just recently been done by one of our customers, a public broadcaster in Germany, the ARD group, who were using Flix transcoder with Frameformer for converting content coming from the Olympic Games in Tokyo and applying high quality motion compensated conversion to them with our combined solution. Now, even event-driven organizations that need frame rate conversion frequently may not have the volume of events to just justify the cost of running these on-premise applications, or there's just simply spikes in demand where hardware that a company might own is just not enough to handle the peak. So in this case, this is really where a SaaS offering comes in and starts making a lot of sense. And now that we're talking about collaboration in the cloud here, this is where we added the collaboration with M2A, with adding their SaaS and event engineering expertise with our combined product, which has then become the M2A CONNECT cloud frame rate conversion solution. And with that, I will hand over to Valentijn.
Hello. So let's roll back just a little bit. M2A was established in 2016, and right from the start, started offering event-based orchestration of cloud media services for OTT. That means everything in terms of virtual infrastructure, but it's real in the cloud, only exists during the event. We throw it all away after the event. So that means it is a pay-as-you-go cost model. Today, in 2021, M2A has extended this vision by applying the same principles to contribution networks video production. This service is called M2A CONNECT, and Callum is just showing, the official slide. The service is called M2A CONNECT, and it delivers an event-based contribution solution with additional services. One of these additional services is, of course, frame rate conversion. Again, based on a pay-as-you-go model. So on a per event, per destination level, M2A, together with partners InSync and Hiscale, can now deliver a flexible and dynamic frame rate conversion solution. Callum, can you go to the next slide? So you can plan when do you want to do what in terms of channel and contribution and flow. And M2A will handle all the orchestration and global availability of your in and outputs, and of course, the additional services like frame rate conversion. Apart from planning the events, if you go to the next slide, M2A CONNECT also supports dynamic patching of sources and destinations, as you can see here. By connecting the boxes with virtual cables, you define a flow. For example, in just one source, in one case, there's just one source flowing from A to B. Let's say that is the orange thing you see there. In another case, you are following, let's say, the white line, where you can say another source is connected to frame rate conversion and then further downstream to the destination. But the same source is not processed and just flowing through. You can patch this all together. On the next slide, you can see schematically how things fit together here. M2A CONNECT delivers value by providing flexibility in cost and capacity in planning which are typical for cloud video solutions. We work with some of the biggest names in broadcast, helping them to connect with new audiences, realize greater potential benefit, and reduced operational overhead. And now we also provide frame rate conversion as part of this service. And now back to Callum.
Thank you very much, Val. I appreciate it. So just 1 second. So we've heard quite a bit there about cloud frame rate conversion and the way the three companies are working together. I just wanted to go on to Conversation Street. Let's have a quick conversation here about the solution. So I noticed one of the things that are still coming up a lot within the industry at events like the DPP, and I'm sure what would have been IBC in a couple of weeks, people still having this hardware cloud debate. Now, James, if live motion compensated standard conversion has been dependent for a long time on hardware solution, is there any implication on quality by using a software solution in the cloud?
Well, that is a question that does crop up frequently. And I think there is perhaps a sense that somehow a hardware solution is inherently superior to a software solution, perhaps particularly in this field. I tackle that question from a couple of perspectives. So first off, I think it's fair to say that motion compensated frame rate conversion is a specialist field. And so the fact is that hardware hasn't been dominant in this area as much over time. So it's really entirely reasonable to expect that the hardware solutions aren't necessarily always delivering the most cutting edge, the most recently developed algorithmic solutions. And the flip side of the coin is, of course, software is so much more amenable to advances in the algorithmic method, just amenable to iterative processes and machine learning, etc. So we would say that actually software is going to be the most cutting edge answer. There is sometimes a sense that maybe live accepts more of a compromise in quality, but we've not taken that attitude at all. We're expecting to deliver a maximally high quality solution with this answer.
Definitely. That's obviously whether they're going for your hardware or software products, you want equally great quality at the end of it. And so Christoph, we've heard a lot today about from both yourself and James about how this solution runs on CPU and not GPU. So for some of the audience who maybe like me are not entirely clear on the benefits, can you just give us an idea of what the tangible benefits of this means for broadcasters and the end users?
Sure. So from our end, the Flix products, we do support NVIDIA GPU acceleration for certain codecs, but in general, just GPUs add a significant cost to overall calculations, both if you purchase them for on-premise installations as well as in the cloud, finding compute nodes with GPU acceleration. And while the availability for these compute resources with GPUs has increased in the recent years, it's still something that's not generally available everywhere in all regions or for all cloud providers. So whereas CPU-only machines are literally everywhere and on all regions and all providers. On the other hand, just not too long ago, it was literally necessary to accelerate live transcoding processes using GPUs. The processors have evolved over time. So even the last 5 years, there's been immense growth in processing power and capabilities. They're just simply no longer necessary for handling live conversions.
Great. And then I think really what we can see with that is really not just flexibility in terms of financial model, but the flexibility in deployment model what comes across clearly from that. And And then Valentijn, finally for you, so where next do you see the development of both this feature and other features going within M2A Connect?
I think M2A Connect will just, let's say, go for additional value in, let's say, video processing or playout. So the final goal will be, I think, or we should go for, is, let's say, cloud playout and connecting with the graphics, the overlays, frame rate conversion, I don't know, audio, maybe color conversion as well. So we will just, since we transport the video, we can also create video if we have playout on board. We can apply things to it, frame rate conversion, logo inserts, graphics, and we can route it as well. So I think the additional services on top of M2A Connect will just be richer and make life easier in terms of event-based video production.
Great, thank you for that, Valentijn. And what I'm just going to do now is I'm just going to switch back over to the screen share and switch to audience Q&A. So thank you for those who have sent questions through. I'll start off with the first question, that being, can you convert 4K footage?
So let me answer that. Valentijn can nod his head if I'm correct. I think the M2A Connect service does support 4K.
Yes, we do. Yeah.
So there's a yes in the answer, but there also comes a no. So for the frame rate conversion part, this is not yet available for processing 4K content. Just, simply because this is a quite an extra amount of pixels that needs to be processed coming from HD resolution. And it's very demanding, obviously, on CPUs, and it really scratches the limits of what's currently possible on, latest generation hardware. So both, as this is where the industry is moving towards to, this is something that we're both InSync and Hiscale are looking into. We're currently working on that, optimizing both our engines, testing on latest generation processors. And while this is not available today, it will definitely be available next year.
Thank you. That's good to hear. And I just had another question come through, and that is, what scaling algorithms does it use? I think that might be to James, that question.
So within this particular deployment, the core frameformer engine is purposed to deliver the frame rate conversion. So we have a number of scaling algorithms, some linear, some non-linear for different applications available in the software. But for this particular service, the frame rate bridge is being achieved at the same resolution.
Great. Thank you. I'll leave the experts to that question. And finally, one last question. Do you exploit AI or machine learning?
Yes, simple answer there. In particular, we routinely exploit supervised learning to gain insights and optimize processes. And depending on your definitions, the regression and statistical techniques may qualify.
Thank you. And I just have one more question. People are getting them in right at the end. And it's just no problems. We are just going slightly over time. So hopefully people can stay around for it. Is JPEG XS in-out supported? And does it support AWS CDI outputs for uncompressed output once the conversion has been done? I think this will be between all three of you, this answer.
I think in terms of transport, this is just, let's say, where the connector sits and how much data is flowing through it. But on the other hand, I think we can just, let's say, peel this question down. In terms of transport, there is no problem, but Christoph might have some more about encoding and decoding, about JPEG XS and CDI as in and output connections.
I do have to say I'm not 100% on the answer. I think at this stage JPEG XS is not supported, but I would actually need to confirm that really again.
Okay. If you, I haven't got a name on that question, so if you want to drop
That's
us
true.
a LinkedIn question, a question to me on LinkedIn or email, feel free to do that, and we'll try to get you clarification on that answer. Okay, great, and that's it on the questions. So let me just bring back up the screen share. So before I say thank you, I would just like to give everyone a quick reminder, a quick plug for my other M2A Talks webinar coming up on Monday, the 29th of November, which is Where Next on the M2A roadmap. So this will be focusing a bit on frame rate conversion, but also on the wider M2A portfolio. So if you wish to register for that again on the Zoom platform, scan the QR code because we are in 2021 after all, or go to the web link bit.ly/2022 roadmap if you prefer doing so that way. And all that's for me left to say is thank you, vielen danke, bedankt to you all for joining today. Thank you to our panelists, Christoph, James, and Valentijn. And as I said, please connect with us on LinkedIn, follow our companies to keep up to date on the latest developments. And I hope you have a wonderful festive season, New Year, and see you soon. Thank you so much. Bye-bye. Right. Stop there.